energy and work. Learning about simple machines. From the very beginning, man has been trying to find ways to make his work a bit easier. The tools that early man made were very simple, but some of them are still being used till today. The wheel is a great example of an early discovery. So, a machine would be a mechanical or electrical device that changes energy to help human beings perform their tasks. So, every machine can be grouped into 5 types of machines. No matter how complicated they may be, they are combinations of these simple machines. Some that you see in your everyday life. This drink is going to make me strong. If only I can get it open. Whenever we need to open a lid of a tin, we use the handle of a spoon to lift the lid of the can. Hey, you've created a simple machine. The stick helped you the same way as the handle of the spoon did. They both are called levers. We saw that the lever was the stick. The force that you use on the lever is called effort. The weight that we are trying to move is called the load. The point of the lever that does not move, which in our case was the small stone, is called the fulcrum. So, in the examples we looked at this far, the fulcrum was in the middle, and the effort and load were at the other ends. So we learn that there are 3 classes of levers too, depending on the relative positions of the effort, load, and fulcrum. When the fulcrum is between the load and effort, as we saw in our examples where, this lever becomes an example of a first-class lever. Examples of first-class levers are a scissors, crowbar, and seesaw. In the second-class lever, the load is between the fulcrum and effort. The best example for this would be a wheelbarrow or a bottle opener and even a nutcracker. This boy is fishing an example of a third-class lever. The load is the fish that has been hooked. The fulcrum is the hands of the boy and the effort is in the rod that is being pulled back. So, a third-class lever is where the effort is between the load and the fulcrum. The invention of the wheel has been among the most definitive inventions in the history of man. Imagine what life would be without wheels. No bicycles, no buses, no vehicles. Oh, a whole lot of walking. The wheel in itself is not a machine, but once you add an axle, it becomes a machine. This axle is simply a smaller wheel that has been fixed tightly to the larger wheel so that both turn together. Let's make a wheel and axle by ourselves. If we use an old thread reel from your mom's sewing kit, push in a pencil in the circular hollow of the reel. Ensure that the pencil is pushed in real tight. Now when you rotate the pencil, the reel rotates too. Now, if you tie up a thread around the reel and rotate the pencil with your fingers, you can easily pick up an eraser or any other little load. So, The load is your eraser and the effort is made by the fingers on the pencil. The wheel and axle can be found in old-fashioned wells. The wheel and axle can be found in your bicycle wheel too. The wheel and axle arrangements can be used to lift real heavy loads too. How heavy load the wheel can lift depends on how many times the wheel is larger than the axle. That means if the wheel is about 9 cm while the axle is 3 cm, this means that the wheel is 3 times larger than the axle and thereby the wheel effort can lift a load 3 times as heavy as the effort. The pulley is simply a grooved wheel. Sometimes it may be a combination of grooved wheels. A single pulley is a simple lever which helps change the direction of a force. The pulley used together with a rope or chain can be used to lift heavy weights. A fixed pulley is fastened by means of a hook to support. A movable pulley is fastened to the load. We find a simple pulley commonly on flagpoles. The flag is tied to a rope which goes around the pulley. The pulley is fixed at the top of the flagpole. Pulling the rope downwards, the flag is raised. By pulling the other end of the rope, the flag is raised and the direction of the effort is being changed to raise the flag. In some cases, a combination of fixed and movable pulleys are used. When a heavy load has to be lifted on to a higher end, it gets really difficult, right? So what can we do? Use an inclined plane to help. We find roads that are built on mountains too have inclined planes. The slide in the playground is an inclined plane too. So, an inclined plane is used to help raise a weight that is too heavy. So, the effort becomes lesser, but the effort has to travel a greater distance than the load. So, whether the inclined plane is long or short, the amount of work done is the same. It only is easier to move the load. A screw is an inclined plane wrapped around a rod, cylinder, or pole. Let's take a triangular paper and wrap it around a pencil. We have made a screw. When a screw is turned one full round, it advances a distance equal to the space between the two neighboring threads. This is called the pitch of the screw. A screw with a bigger pitch is more difficult to screw into a piece of wood instead of a screw with a smaller pitch. We also use a screw instead of nails to hold two pieces of wood together better. A windlass is a continuously moving lever. One part of a windlass is a drum on which a rope is wound. The rope can also be unwound. The lever helps to turn the drum. Windlasses are used to raise and lower elevators. Of course, it is a windlass that is used to lower or raise a bucket into a well. Summary. We've been learning all about simple machines. Look all around you, and you are sure to find these machines making our work just a little easier. Keep trying to relate these machines to what you've learned.